In order to understand the concept of energy, you need to understand the concept of work. So let's start our class with a discussion on work. What does work means, and when does work get done? In science, work is actually done by force. Now, not all forces do work. In order that a force may do work, that force needs to produce motion. Now, if I apply a force on the screen, I am applying a force, but that force is not producing motion. Therefore, that force is not doing any work. Now, if I keep this on my head, I am applying a force to keep it there. Am I right? My head doesn't have anything to support it. Now you notice that I am applying a force on this, and the cart is applying a force on me, and none of these forces is doing work. Why? Because these forces do not produce motion. Now look at each of the picture I'm going to throw on the screen and see which force is doing work and why or why not. Alright, here you have somebody pushing a wheelbarrow. Tell me, work is being done? Alright, work is done by the force. He is applying a force on the wheelbarrow and the wheelbarrow is moving. Work is done. How about this frustrated computer typist? Well, of course, there is a force and that force produces motion. It is banging on that screen and it is moving. It produces work. How about this? Somebody comes and opens the mailbox. The force produces motion. Work is done there. And how about this? A muscle man is holding a computer. Now, is the force involved in here doing work? Well, actually not. There is no work done in this case. So, do all forces produce motion? What's the answer? If a force does not produce motion, that force does not do work. So, not all forces do work. Is the man holding the computer doing work? No. Why not? Because the force he is applying is not moving. So if I ask you, make a list of 5 forces that do not do work and 5 other forces that do work, would you be able to do it for me? Well, now measure work. How are we going to measure work? Work is measured as the product of force and the distance the force moves. Very simple concept. So work equal to force multiplied by distance. Can you tell me, what is the unit we are going to measure work? The unit of work will be the unit of force multiplied by the unit of distance. Tell me, what is the unit of force? Force is measured in Newton. Distance is measured in meter. So the unit of work will be a Newton meter. Force is measured in Newton. Distance is measured in meter. Therefore, the unit for measuring work is the Newton meter, and it has a name. The name of Newton meter is a joule. So tell me, what is the unit for measuring work? Work is measured in a unit called the joule. And a joule is a Newton meter. Very important information. Now, what is the force needed to lift a 5 kilogram box? I have a 5 kilogram box. Over here, I have a box that has a mass of 5 kilogram. what is the force I need to lift it? Alright, can you tell me what is the force I need to lift it? First of all, you should understand the box has the weight. Alright, what is the weight of a box that has the mass m? If you remember our last class, if a box has a mass m, its weight is m times g newtons. What is g? G is acceleration due to gravity. You see that? So if I want to lift that box, I need to apply the same amount of force upward. Then only I will be able to lift it. Alright, let me draw that diagram for you. Here is the box, and the box has a mass of 5 kilograms. Therefore, what is the weight of that box? The weight of an object is mass multiplied by acceleration due to gravity. 5 times 9.8, that is 49 Newton. So the weight of the box is 49 Newton, and that is acting vertically down. If you want to lift that box, you need to apply a minimum of 49 Newton upward so that you can balance the weight. So a force of 49 Newton upward is required to lift it. Alright, so if I apply a force of 49 Newton, I can now lift it because there is no net force there. Okay, suppose I lift the box now by 2 meters. Now watch here again. What is the force I'm applying? I'm applying a force of 49 Newton. And I'm going to move that through a distance of 2 meters. Look, the box is now placed there at a distance of 2 meters above. So, the force I applied, this 49 Newton, moved a distance of 2 meters. Tell me, what is the work I did? The work I did is force multiplied by the distance. And that is 49 Newton multiplied by 2 meters, that is 98 joules. So, a box, now remember I told you in the last class, mass and weight are two different things. The mass of this box is 5 kilograms. Its weight is 5 kilograms multiplied by G, 9.8. That is 49 Newton is acting vertically down. In order to lift that box, I need to apply a force of 49 Newton in the upward direction. And now I apply that force and move it through 2 meters. The work done is 98 joules. Alright, I hope you understand that concept. Okay. What is your mass in kilogram? Do you know your mass in kilogram? If you have a bathroom scale, now find your mass in kilogram. Now those scales will be marked in pounds as well as in kilogram. We don't use pounds, so we will use kilogram. If you can find your mass in kilogram, do that now. Now, once you know your mass in kilogram, you can find your weight in Newton. How? Multiply your mass in kilogram by 9.8 meter per second squared. That will give you your weight in Newton. Okay, so make a note of that. I'm going to do that for myself. My mass is 55 kilograms. So I'm going to say my mass is 55 kilograms, and I'm going to write that down here. What is your mass? And say that is 55 kilograms. What is my weight? That will be 55 multiplied by 9.8. Can you tell me what is 55 multiplied by 9.8? That will be 539 Newton. So, My weight is 539 Newton. Now, I'm going to ask you to do something else, and that is, I'm going to take that off. Remember, my weight is 539 Newton. Alright, if you now climb upstairs a height of 3.2 meter, suppose you now climb upstairs, you are actually lifting your own weight. That's how you climb, is that right? If my weight is 539 Newton, I have to apply 539 Newton upward to lift myself. If I want to jump up, I have applied a force of 539 Newton upward. So when you climb stairs, you are lifting your own weight. So what is the work done to do that? So when you climb stairs, you are lifting yourself 3.2 meter. Okay, now can you calculate the work I do when I climb these stairs? You remember my weight? 539 Newton. And that 539 Newton is moving through 3.2 meter. Calculate the work done. Work done is force multiplied by the distance. So that will be 539 Newton multiplied by 3.2 meter, and whatever you get as the answer, that will be in joules. So since you are lifting your weight up, the force that is moving is your weight. Multiply your weight with the height you climbed to get the work done. Alright, let's do a small problem. You have 5 books, each of mass 2 kilograms, lying on the floor. You want to lift them to a bookshelf 1.8 meter high. What is the total work you need to do? Well, if each book is 2 kilograms, can you tell me what is the force I need to lift that 2 kilogram books? Well, the mass of one book is 2 kilograms. There you are. This is the book. Its mass is 2 kilograms. What is its weight? Weight of one book will be its mass times g. That will be 2 kilograms times 9.8 meter per second squared. That is 19.6 Newton. In order to lift this book, I need to apply 19.6 Newton upward. Is that right? So the weight of this book is 19.6 Newton. This 19.6 Newton force you apply on it to lift the book upward. And how much do you have to lift it? You got to lift it through a height of 1.8 meter. So work done is force multiplied by distance. You apply this force 19.6 Newton and move that through a distance of 1.8 meter. At the bookshelf, you got to take it all the way there. What's the height you got to take it? 1.8 meter. Therefore, the book now is lifted through a height of 1.8 meter to place it there. What is the work you did on one book? It will be 19.6 Newton times 1.8 meter. That is 35.28 joules. So to lift one book from the floor to keep it on the shelf, you did 35.28 joules of work. Now therefore, what is the total work done to put 5 books on the shelf? Multiply this number by 5. That will be 35.28 multiplied by 5. That is 176.4 joules of work. Okay, let's do another one. A man applies a force of 150 Newton on a wheelbarrow and pushes it through a distance of 22 meters. What is the work done by the man? I'm sure you can do that. He pushes with a force of 150 Newton. That is the force he applies. And how much does that force move? Well, he comes here a distance of 22 meters. What is the work done? Work done is force multiplied by distance. Force is 150 Newton. The distance is 22 meters. So that will be 150 Newton multiplied by 22 meters, and that is 3,300 joules of work. Alright. Let's now talk about power. What is the meaning of power? You see, if we say one person is more powerful than another person, one car is more powerful than another car, what does that mean? What it means is that the powerful person can do a piece of work much faster than another person. A powerful car can do the same work much faster. A powerful car can go from 0 to 90 much faster than another car. In other words, power is a measure of the rate of doing work. If one person is able to do a piece of work much faster than another person, then we say that the first person is more powerful. So obviously, power is a measure of the rate at which work is done. You see, you notice how many times we come across this term rate. Every time a new term comes, we come across that. Power is the rate of doing work. So can you write down that as an equation? Alright, let's take the wheelbarrow man. Now, how much work does the wheelbarrow man does in moving it through 22 meters? If the man pushing the wheelbarrow takes 10 seconds to do the work, how much work did he do? It is 150 multiplied by 22 meters. So the work done in 1 second will be the total work done divided by the time. He did the total work done in 10 seconds. He's very powerful. He did that much of work in 10 seconds. So the total work done divided by the time taken is a measure of the rate of doing work, which is 3,300 joules divided by 10 seconds, and that is, look at the unit now, 330 joules per second. The unit of power is a joule per second, rate of doing work. So, if another person does the same amount of work in 20 seconds, the work done in 1 second for that person will be 3,300 joules divided by 20 seconds, and that will be 165 joules per second. So the power of the first man is 330 joules per second. The power of the second man is only 165 joules per second, because the first one did the work much faster. Alright, since the second person did more work in 1 second, well, is that true? No. The first person did more work in 1 second, 330, so you must correct that second to the first. The first person did more work in 1 second, therefore that first person is more powerful than the second person. Alright? Okay. Work done in 1 second is the rate of doing work. So what is the definition for power? Power is the rate of doing work. Power is a measure of the rate of doing work. And how do you write that as an equation? Power equal to work done in joules divided by time taken in seconds. Rate of doing work. Total work done divided by the time taken is a measure of the power. What is the unit for the power? Joules per second. And it has a name. Joules per second is called the watt. Actually, it is the name of the scientist who first invented it, James Watt. So the unit joules per second is called the watt, and we represent that by the uppercase W. Power is measured in watt. Now, we use that every day in our life. Now, remember, everything we talk and do in this class are things that we use and experience and come across every day. Now, an average horse is capable of doing approximately 746 joules of work in 1 second. In the ancient days, power used to be defined in terms of the work that a horse can do. Now, it has been determined that an average horse can do 746 joules of work in 1 second. Therefore, the power of a horse is 746 joules per second, which is 746 watt. And this is what we call a horsepower. Now, when you go and buy an electric motor which says on it 1 HP, what does that mean? It means when you connect that motor to the electric supply, that motor will do 746 joules of work in 1 second. That is the meaning of that, a 1 horsepower engine. Alright, horsepower, abbreviated as HP, is generally used in measuring the power of electrical appliances. When you buy a motor or an air conditioner or anything, it is rated for HP, horsepower. A 3.5 horsepower engine will do how many joules of work a second? 1 horsepower engine will do 746 joules of work a second. So a 3.5 horsepower engine will do 746 multiplied by 3.5 joules in 1 second. So 1 horsepower is 746 watt. Alright. For measuring large quantities of power, we use the kilowatt and the megawatt. I'm sure some of you at least must have heard about it. A kilowatt is 1,000 watt. A megawatt is 1,000,000 watt. So these are common units that we use for measuring large quantities of power. Now, 1 kilowatt is 1,000 watt and 1 megawatt is 1,000,000 watt. Now tell me, what is the meaning of a 60 watt bulb? Don't you sometimes go to the store and buy a 60 watt bulb or a 40 watt bulb or a 100 watt bulb? Yes. What is the meaning of a 60 watt bulb? What it means is, when you plug that 60 watt bulb into your light socket and turn it on, that bulb will use electrical energy at the rate of 60 joules a second. So that bulb will use up electrical energy 60 joules in 1 second. That is a 60 watt bulb. A watt is joules per second. So a 60 watt bulb uses electrical energy at the rate of 60 joules every second. Now, what is the meaning of a 2 horsepower motor? A 2 horsepower motor uses electricity at the rate of 2 times 746, which is 1492 joules of electrical energy every second. Okay? I hope that is clear. Every electrical appliance is rated for its power. If you look around your home, you have many electrical appliances. You have a cooking range or a stove in the kitchen which is rated, say, 1.5 kilowatt. What does that mean? 1.5 kilowatt. 1,500 joules per second. That will use up energy at 1,500 joules per second. Now, your water heater is rated. I would like you to look around and find the electrical power rating of each of these equipment. Let's do a lab of electricity. You see, electrical power, we use electrical power at home and we pay for it. Now, how do we pay for it? What is a unit of electricity? We pay for electricity for each unit we consume. Now, what is a unit of electricity? I will explain a unit of electricity. Now, listen to this carefully. If a 1000 watt bulb is left on for 1 hour, how many joules of electricity is consumed? What is a 1000 watt bulb? A 1000 watt bulb uses 1000 joules of energy every second. You see? A 1000 watt bulb consumes 1000 joules of energy in 1 second. Now, if you leave this on for 1 hour, how many joules of energy are consumed? 1 hour contains 3,600 seconds. Therefore, the amount of energy consumed by this bulb in 1 hour is the amount of energy used in 1 second, that is 1,000 joules, multiplied by the number of seconds in an hour, 3,600. That will be, now, 36 followed by 5 zeros, or it is about 3.6 million joules. And this much energy is called a unit of electricity. A unit of electricity. So when you use 1 unit of electricity at home, it means this much energy is 1 unit of electricity. And that 1 unit of electricity has a name. It is called a kilowatt hour. 1 unit of electricity is called a kilowatt hour. Now, how do you obtain a kilowatt hour? Well, all you need to do is write the power in kilowatt. In order to calculate the number of units, you always have to write the power in kilowatt. So write the power in kilowatt and multiply that by the time, the number of hours, and that will give you the number of units. A kilowatt hour is power in kilowatt multiplied by the time in hour. Okay, let's do a problem to understand that. A 500 watt electric water heater is turned on for 2 hours every day. How many units of electricity are consumed in a month of 30 days? If electricity costs 10 cents a unit, what is the cost of heating water for a month? Okay, how do we start? We need to find the number of units used per day. Now, how do you calculate the number of units? Step 1, write the power of the appliance in kilowatts. So I'm going to give you various steps you can follow. In step 1, write the power of the appliance in kilowatt. So our power is 500 watt, but you can't leave it in the watt. You've got to convert that to kilowatt. You see, 500 watt is a half of a kilowatt. A kilowatt is 1,000 watt. So 500 watt is 0.5 kilowatt. Step 2, obtain the time in hour. We are told that it is used for 2 hours every day. So the time in hour, since we are looking for the monthly bill, we got to find the time in hours for a month. 2 hours every day, multiply that by 30, it gives me 60 hours. We use the heater 60 hours a month. So we got the power in kilowatt, the time in hour. What you do in step 3, obtain the number of units used. A unit is a kilowatt hour. So multiply the power in kilowatt by the time in hour. That will give you the number of units. Look at the number of units. It's 0.5 kilowatt multiplied by 60 hour, and that is 30 kilowatt hour or 30 units. Your water heater has consumed 30 units of electricity in 1 month. So you pay 10 cents for each unit. Therefore, what is the cost of using that water heater? 30 kilowatt hour, that is 30 units, multiplied by 10 cents, that is 300 cents or $3. I want you to follow these steps. For every calculation you want to do for every electrical appliance, follow these 4 steps. Okay? And I want you to do this for some of the electrical appliances at home, and that is your lab 6. You see, this lab is simply an exercise to make learning. Okay, let's now go and discuss another concept, energy. What is the concept of energy? Now, energy, the concept of energy is what I told you is the theme of this unit. And in order to build in the concept of energy, we talked about work and power. Well, have you heard somebody say, I have no energy to do anything today? What does that mean? I don't feel like getting up. Well, what that person means is, I don't feel like doing any work. Therefore, what is actually energy? If that person don't have energy, that person is saying, I don't have the ability to do any work today. You see that? Energy and work are closely related, and energy is defined as the ability to do work. If I am able to do work, I have energy. If something else is able to do work, that has energy. You see that? When you raise a hammer, look at that, raise something and bring it down on something, that did work. Did you hear that? Yeah. It did work because it had the ability to do work. Anything that has the ability to do work has energy. And the energy is measured in the same unit as work, because energy is the ability to do work. Alright, when a crane raises a heavy object, work is done on the object. This work done on the object gives it ability to do work. And an object that is raised to a height has energy. Now, in other words, if I raise an object, let me see if I can find an object to show you. If I can raise this object, now what I'm doing is, I'm doing work in raising it. Now, in raising it, I have given energy to this, because now if I drop it, it can do work. Now, do you like me to drop something like this on your foot? No, because by raising it, I have given it energy. And that energy is stored in it. And this is now capable of doing work. In the same way, if you stretch an elastic band, you see, I'm sure most of you know, you have played with these kind of things in your school when you were children. Is that right? If you stretch an elastic band, that can do work. How many of you have thrown a stone with an elastic band? You're stretching the elastic band, you do work on the elastic band. That means the elastic band can now do work. Alright, we now talk about potential energy. What is the meaning of potential energy? Since a raised object has the potential to do work, any raised object has the potential to do work. Now, when I raise this block of wood, now, believe me, I'm going to bend down and raise it from the ground. Look at that. I have raised this piece of wood. Can you tell me how much is the work I did? In order to raise it, I have to apply a force equal to its weight. What is the weight of this block? M times G. And that M times G, the force I applied, I moved it through a height h. The work I did is M times G, which is the weight, multiplied by the force I moved it, mgh. Now that much work I did on this block, and this block, now if I release it, can do the same amount of work. This block now has the potential to do work, has the ability to do work. Therefore we say this block has potential energy. Now just listen to this. If I drop it, the work that this is able to do. Yes. It has the potential to do work. Therefore a raised object has potential energy. When you raise a ball, a crane raises the ball, it gives potential energy to the ball, and you know that ball can then be used to do work. The ball is used to demolish a home. A bow, when you stretch it, the stretched bow has potential energy. It has the ability to do work on that arrow. So the raised ball has potential energy. A stretched bow has potential energy, and it is capable of doing work on the arrow. So the energy of an object as a result of its position or state. This ball has potential energy because of its position. This block of wood has potential energy because it is being raised to this position. And the stretched bow has potential energy because of its state of being stretched. So, the energy of an object as a result of its position or state is called potential energy. And look at the way we are going to denote that. We will use the symbol uppercase U to represent potential energy. So from now on, when you want to represent potential energy, it will be the uppercase U. Okay. And it is a measure of the work done. Potential energy is a measure of the work done to place the object in that position. So what is the potential energy of this block of wood? It is a measure of the work I did to place this block in this position. And how much work did I do? I'm going to do that again. Tell me, how much is the force I need to apply to lift it? Its weight. And what is the weight of this block? It's mass times G, mg. So I'm going to apply a force mg. Alright, watch me do that. I'm applying a force mg and moving that force mg through a height h. There we are. Now, I have done an amount of work mg multiplied by h. And therefore, this block now has a potential energy equal to the amount of work I did, which is mgh. Alright. When a weightlifter lifts the dumbbell, now look at that. When he lifts the dumbbell, he's actually doing work so that the weights will gain potential energy. Suppose m is the mass of the dumbbell. What is the weight? Its weight will be mg. You see, the mass is m, its weight will be mg. You need to apply a force mg upward to lift it. And it is lifted through a height h. Therefore, the work done to lift the weight is its weight mg multiplied by h. So the work done to lift an object is mgh. M is the mass of the object, g is the acceleration due to gravity, h is the height of lift. So potential energy of an object of mass m placed at a height h. What is the potential energy of an object placed at a height h? Is mgh. How do we write it? Look at this. U stands for the potential energy. U equal to mgh. Potential energy of an object of mass m placed at a height h is mgh. Now, potential energy of an object at the ground level we will consider to be zero. In other words, when the block of wood is lying on the floor, its potential energy is zero. And when it is lifted through a height h, it has a potential energy U equal to mgh. I hope that is clear. So when the weightlifter raises this dumbbell, it has the potential energy U equal to mgh. And on the ground, its potential energy is zero. Alright, a simple problem. Find the potential energy of an 18 kilogram iron ball raised by a height of 12.4 meter. Alright? We got the mass, we got the height, and you know the value of G. The potential energy equal to mgh. Mass is 18 kilogram, G is 9.8 meter per second squared, H is 12.4 meter. Therefore, the potential energy is the product of all these. Can you multiply these three numbers? Now keep a calculator with you when you listen to the lectures. That will be 2,187.4 joules is the potential energy of this 18 kilogram iron ball raised by a height of 12.4 meter. Now that means it is now able to do this much work. If you now let that ball go, it will come down and do this much work. That's why we say that's the potential energy. The ball now has the potential to do this much work. Alright, let's now talk about a second type of energy called kinetic energy. Kinetic energy. What is kinetic energy? What does kinetic means? Kinetic is motion. Energy of motion. You see, a moving object has energy. Have you ever tried catching a very fast moving baseball? Well, if you try, you know how stinging it is on your hand. Why? Because a moving object can do work on you. You see, a moving object has energy. A moving object has the potential to do work. You see, and the ability of a moving object to do work is called its kinetic energy. Alright? So work done on an object can also result in speed of the object. Now, if I want to throw this, if I can do work on this by throwing it. I don't want to throw this one now. Then it will acquire speed. Now, this can go and hit something and do work on it because of its speed. So, work done on an object can also give an object speed. Look at that. You hit a golf ball, you do work to hit, is that right? You do work to hit the golf ball. And the work you did give the golf ball its speed. And the golf ball in turn can do the same amount of work when it is stopped. Now, when a golf ball is hit, work is done on it and gives the golf ball its speed. The energy of an object due to its speed is called kinetic energy. And we will represent kinetic energy by the uppercase K. So, we have two types of energy now. Potential energy, we represent that by the uppercase U. Kinetic energy, we represent that by the uppercase K. And kinetic energy is the energy of an object because of its motion. Kinetic energy of an object of mass m having a speed v. I'm going to give you an equation for kinetic energy. Try and remember this. Kinetic energy of an object of mass m and having a speed v is k equal to 1/2 mv squared. Kinetic energy equal to 1/2 mv squared. Alright, an important formula. So you got two formulae to remember now. Potential energy. What is potential energy? Let's write those formulae. Potential energy is U equal to mgh. Kinetic energy K equal to 1/2 mv squared. So don't forget these two types of energies. Potential energy and kinetic energy. Alright, let's move on. Now, kinetic energy depends not only on the speed but also on the mass of the moving object. 1/2 mv squared, right? So, the kinetic energy depends on the speed, and if you got two objects having the same speed, but one has a bigger mass, then this has a greater kinetic energy. The object with larger mass has a larger kinetic energy. Now, what is the kinetic energy of a 15-gram golf ball that has a speed of 22 meters per second? Well, I gave you the mass, I gave you the speed, you used the formula, kinetic energy is 1/2 mv squared. But before you do that, make sure that your mass is written in kilogram. Remember the fundamental units I told you? The unit of mass is the kilogram. Tell me, 15 gram is how many kilograms? A kilogram consists of 1,000 grams. So 15 gram is 15,000 of a kilogram. Divide 15 by 1,000, you get 0.015. So mass is 15 gram, that is 0.015 kilogram. Velocity is 22 meters per second. Therefore, kinetic energy is 1/2 mv squared. I want you to practice this. So take a calculator and do this. That will be 1/2. On your calculator, for 1/2 you can punch in 0.5. 0.5 times 0.015 times 22 squared, and that is 3.63 joules is the kinetic energy of that object. Okay, so you must be able to calculate kinetic energy and potential energy using the two formulae. We will be doing a lab soon in the second part of this lesson. Alright, 16 joules of work was done on a bowling ball of mass 0.5 kilogram. If all the work becomes kinetic energy of the ball, what is its speed? Well, this time you are given the energy, the total work done. The total work done is 16 joules, and all that work done became kinetic energy. Now, that means I would say work is 16, that will be equal to 1/2 times m is 0.5 kilogram times v squared. The total work done is 16 joules, that is the kinetic energy. And that kinetic energy is 1/2 m v squared. Mass is 0.5 kilogram. Can you now simplify this? Multiply both sides by 2. What will happen? If you multiply the left-hand side and right-hand side by 2, you get this. Is that right? Now the left side now becomes 32. On the right side, the 2 and the 2 cancels. You got 32 equal to 0.5 v squared. Now, we need to find v, so isolate v squared. Divide both sides by 0.5. What does that give you? Now that would be, I'm going to use the right hand side. 0.5 v squared divided by 0.5 equal to 32 divided by 0.5. And on the left, the 0.5 will go. We get v squared equal to, do you know what is 32 divided by 0.5? It's 64. Alright, tell me, if the square of v is 64, what is v equal to? V equal to 8 meters per second, because 8 times 8 is 64.